Good morning, good afternoon, good evening, class. This is Mr. Arosenna, and today we're going to talk to you about electrostatics. All right. So the last time we saw this, at least at NVSS, was I think Science 9, and we had a very brief look at what electrostatics and what they did. Probably today will basically just be a review about electrostatics as well. All right. So first up, we'll talk about the laws of electrostatics. These are three rules that govern how electrostatically charged objects behave. So the first is that if you have similar charges or like charges, that they will repel each other. So if you don't remember from Science 9 or I guess Chem 11, Chemistry 10, basically earlier science classes, objects can have two different charges. Okay, the first charge you can have positive charges, or you can have negative charges. If you have equal amounts of positive and negative charges, then your object is neutral. All right, now, so similar charges will repel. So if you have a if you have two positive objects besides each other, they will repel. And if you have two negative charges besides each other, they will repel as well. Okay. Now, if you have different charges, so if you have a positive and a negative charge beside each other, they will attract each other. Okay, so they will pull closer together. They won't, I guess, they won't push away from each other. They will attract each other. Okay. And then finally, neutral objects. So neutral objects, these objects, neutral objects have equal, positive, and negative charges. Oops, that wasn't good. Yeah, so they have equal positive and negative charges. And now these objects, or neutral objects, they are attracted to charged objects regardless of charge. And we'll talk about that a little bit later. Okay. All right, so these are the three rules of electrostatics. Similar charges will repel. So similar, repel. Different will attract. All right. Now, how do objects get charges? Well, if you remember from Science 9 again, where we first talked about subatomic particles, in Science 9 we discussed that atoms are made of protons, neutrons, and electrons. These are the three sort of parts of an atom that we talked about in Science 9. Now the protons, these have a positive charge. Neutrons are blank, so I'll do that. Neutrons are blank. And electrons have a negative charge. These are just things we remember from Science 9. Hopefully remember from Science 9. Okay. Now, when objects get charged, the only thing that gets moved are the electrons. Because if you notice, the electrons sort of sit outside the nucleus. Okay. And if you remember from Science 9, electrons are kind of loosely, at least the outer electrons are kind of loosely held to the nucleus. So for particularly large atoms and molecules, the electrons in the outermost orbits or outermost shells, outermost energy shell, tends to be not very strongly held, so they can be moved around. So electrons can get transferred. Okay. Now, when the electrons do get transferred, that's how objects can gain a charge. Because if an object gains electrons, okay, then it becomes negatively charged. Okay, and this is what this statement says here, where charge is not created or destroyed. Only electrons get moved. Okay, so when something becomes negative, so becoming negative, this means that you are gaining electrons or gaining more negative charge. And then becoming positive, this equates to losing electrons, loss of electrons. Because if you remember from, again, Science 9, when atoms become positive ions, they lose electrons, and when atoms become negative ions, they gain electrons. It's similar to when an object is positively charged, it just loses a bunch of electrons. If an object becomes negatively charged, it just gains a bunch of electrons. Okay, this is sort of known as the law of conservation of charge, where charges do not get created or destroyed, they just kind of get shuffled around. Okay. So if one object, I guess the best way to put it is if one object gains a bunch of electrons, okay, so if a bunch of electrons suddenly flood to one object, these electrons, these electrons came from another object. They just don't get spontaneously created. Okay. Yeah. So when things get charged, they either gain electrons or they lose electrons. And if something gains electrons, then something has to lose an equal amount of electrons. Okay. All right. Now, in the realm of, I guess, of electrons, electrons can travel through various substances. Some substances are a little easier than others. So this is where we talk about conductors and insulators. Now, what a conductor does, a conductor allows charges to flow through them. So they have a nice molecular structure that allows, I guess, atomic structure. It allows electrons to easily traverse from one atom or one molecule to another. Metals are a very good example of this. Metals have a very structured, or I guess very structured atomic structure, which facilitates the movement of electrons. So this was a sample of a metal. As you know from earlier science classes, metals are arranged in a very orderly manner, such as this. And what will happen is that the electrons, which sit on the outside of the metal, they kind of have these channels which allow them to move. Okay, so these channels allow the electrons to move freely from one atom to the next. Okay. And if you give them enough of a push, you will actually be able to push them through like that. One of the ways that we can give them a push is if we pile a bunch of negative charges on one end. So let's say pile a bunch of negative charges here. Okay, and one of the ways we can do this is with a battery or a balloon charged negatively. Or basically, if you have a pile of negative charges here, because of the first law of electrostatics, where like charges repel, all of these negative charges will repel each other, and because the metals allow them to move with these channels, then the electrons just fly through these channels away from each other. Now, by contrast, an insulator does not do that. So an insulator has an atomic structure that does not facilitate the easy movement of electrons. And generally, nonmetals are very good at this. And part of the reason for that is they do not have an atomic structure that is conducive to allowing electrons to move through them. So here's an example. This is water. Here's a random arrangement of water molecules. So the water molecules have a pretty random arrangement relative to, say, the metal from the previous slide. And when you have an electron, the electrons do not have a clear path to travel in. Okay, alternatively, because water is a polar molecule, the electrons might even be attracted to various parts of the water molecule, so they don't actually move through this sample of water very easily. This is again why if you have a sample of pure water with no dissolved ions, it doesn't conduct electricity very well because the electrons don't actually want to move through, or they don't have an easy way to move through this structure. For example, this electron might fly through here, but then it might get attracted to this part of the water molecule. Because again, this part of the water molecule is, actually that's wrong, that's the negative part. It'll actually get attracted to this part of the water molecule because the hydrogen end is slightly positive, right? So the electrons don't have an easy way to travel from one molecule to another because in this case, water's polarity will attract electrons to here, and there's no easy channel for them to move through. Okay. Now, there are a set of substances which are kind of in between. If you remember from Science 9, these were called dimetalloids. Some textbooks call them semimetals, same thing. And depending on their atomic structure, they can act as both a conductor or as an insulator. A good example is carbon. Carbon can act as a very good conductor if it is in the form of graphite, but in the form of diamond, it's a very good insulator. And their atomic structures will sort of show that. All right, so this first structure here, this is graphite. And if you notice, the graphite is arranged in sheets, very similar, and it has these channels which are very similar to the metal structure I showed earlier. Okay, this form here is diamond, and in diamond, the carbon atoms are arranged in a much more crystalline pattern, and there's no easy channels for the electrons to travel through. So this is what makes graphite a decent conductor, and this is what makes diamond a very good insulator. Okay, other substances will exhibit these properties as well, and they're generally found in the metalloid column, or metalloid staircase, I guess. It's not really a column, it's more of a staircase. But this is where you would find these types of elements or materials, is if they are arranged, or they're on that metalloid staircase, and you can arrange their atomic structure in a way to either facilitate electron movement or to hinder electron movement. Okay. Another very important element outside of carbon that's in the metalloid family is silicon. Silicon does the exact same thing. Silicon can be a good conductor, or it can be a good insulator. Okay, and we actually take advantage of that property of silicon when building our electronic devices. Okay. Yeah, how do you go about charging an object? Charging an object is quite easy. You just have to move electrons. And there's sort of two broad ways to do that. The first is through a method called charging by induction. So in this method, you can charge an object without actually touching it. And this is part of the reason why neutral objects are attracted to a charged object. So for example, if I have, let's take a charged rod here. Let's say this is a positively charged rod. So it's missing a bunch of electrons. And you bring it to a sphere which has a neutral amount. So let's say I have a neutral amount. So a neutral sphere. What will happen here, and I'll change my color so it's a little easier to see. What will happen here is that as you bring this positively charged object closer, the negative charges will want to move towards it. Okay. Now, unless they actually touch, the negative charges will stay on the ball, on the sphere, sorry. But they will all sort of congregate near the positively charged rod. So the negative charges will appear here, but the positive charges will still be over here. So this way, this ball is temporarily negative on this side. And then because of the law of attraction for oppositely charged objects, the ball will actually move towards it. And if they touch, the electrons can then transfer from the from this side over to here. Okay, that's one way to charge. The other way to charge is, let me just erase everything here. The other way to charge objects is through conduction, which is when you charge an object by touching it. So this is where you would charge the object by touching it and physically transferring your electrons. So the electrons get physically transferred. So if I draw the same sphere, but this time I'll touch it. So if this is a positively charged sphere, okay, and there we go, and they touch, it allows the electrons to move over this way. Now when you pull away the rod, so the rod will have positive and negative charges on it. Okay, and then the sphere will be left with a bunch of positive charges but no electrons. So the sphere now becomes a positively charged object. Okay. So those are the two main methods you can charge an object. And the easiest way, I guess, to charge by conduction, you can also use, well, charging by conduction, the easiest way to see this is simply take a balloon and rub it on your head. The act of the balloon touching your head and rubbing will strip electrons from the balloon. I think from the balloon? Yeah. Well, it'll either strip electrons from the balloon to your hair or from your hair to the balloon. And the end result is that your hair is charged, the balloon is charged, and then you can use that to your advantage. Okay. Okay, so there's a quick review of electrostatics. Your assignment for today then is as follows. If you guys have any questions, you guys know how to contact me.